Welcome to this explainer. I'm absolutely thrilled you're here today because, well, we're going to embark on a truly mind-bending exploration of our mathematical foundations. We usually think of math as this ultimate, unshakable truth of the universe, right? It's the language of logic, it's the bedrock of physics, literally the most precise tool we've got. But the fascinating source text we're diving into today, it radically challenges that whole assumption. It actually asks us to look much closer at the stuff we take for granted in math and wonder if some of our most fundamental concepts are actually just brilliant illusions. So get ready to completely question reality.
Okay, let's dive into this. Have you ever actually seen an irrational number? I want you to really stop and think about that for a second. I mean, we all learn about these concepts in school, right? Those numbers that just go on and on forever and ever without repeating. But according to our source material, the answer to that question is a resounding no. No way. The text argues that human experience completely precludes us from ever actually witnessing an irrational number out in the real world. So let's break down exactly why this source is claiming our mathematical eyes are totally deceiving us.
This brings us to part 1, the illusion of irrationals, and a look at what professionals actually use.
And this brilliantly illustrates what happens when we shift from theoretical math to the grounded, everyday world of professionals. We see this really stark contrast. On one side, we've got infinite irrational numbers. On the other, approximations. The text actually makes this super bold claim. Physicists, they've never used irrational numbers. Mathematicians, never used them either. When a physicist is out there calculating the fabric of the universe, they are only ever using approximations of those symbols. Even the purest mathematicians are really just working with approximations, or simply shuffling the symbols themselves around on a chalkboard. The actual infinite number itself is entirely absent from the real work.
Think about it like this. When we look at a page of super complex math, what is physically entering our eyes? The text points out that we've only ever seen symbols, approximations, and finite amounts of ciphers, meaning like individual digits or characters. In fact, we've only ever seen really small amounts of symbols. I mean, it makes sense, right? Human beings are finite creatures. A piece of paper is finite. A computer screen is finite. Therefore, the argument goes, our visual evidence is strictly limited to the finite. We literally cannot see infinity. We can only ever see a tiny, finite representation of it.
So the crucial point is this. Irrational numbers are only symbols, really, and not numbers. The source doesn't mince words here at all. It's actively stripping that number status right away from things like pi or the square root of 2, relegating them to mere symbols. It's a hugely provocative takeaway that suggests our entire mathematical vocabulary might be mislabeled, basically mistaking the map for the actual territory.
Which perfectly sets us up for part 2, defining a number, the missing foundation.
Now, what's really interesting about this slide is that if irrational numbers aren't actually numbers, we have to look at the very foundation of math itself. Notice that glaring error message. According to our source, there is absolutely no proper definition of the word number. Just sit with that for a second. The most basic elemental building block of all mathematics, the stuff we spend years learning how to manipulate and add and subtract, fundamentally lacks a proper definition in reality. It's like we've built this towering skyscraper of mathematical theory without ever properly pouring the concrete for the foundation.
And that brings us to part 3, the myth of infinity. Too big to be a number.
So if the foundation is completely missing, what happens when we try to build that skyscraper all the way up into the clouds? Well, the text states it pretty plainly. No proper definition of infinity exists. Think about it. If we can't even define a basic, finite number, the source argues we certainly do not possess a proper working definition of a concept that literally has no end. It's just a logical continuation of this deeply empirical stance. Basically, if we can't observe it and we can't properly define it, we really have to question its existence in our mathematical reality.
Let's walk through the exact logical steps the text uses to dismantle the mechanics of infinity. Step 1. These symbols we use, well, they represent something that is simply too big to be a number. It completely surpasses the undefined boundary of what a number even can be. And step 2, because it's too big to be a number, standard mathematical operations just completely fail. Therefore, it is impossible to add 1 to these symbols. Actually, if you think about it, you can't add a number to something that doesn't represent a number anymore, right? The mechanics of addition require 2 numbers. If infinity is just a symbol for something impossibly large, adding 1 to it is just a meaningless operation.
Let's move to and see how this builds into one of the most colorful and honestly surprising comparisons in the entire text. Infinity is just a nonsensical object like a fairy or a gnome. It is such a brilliant, whimsical way to illustrate a deeply serious philosophical critique. I mean, the author is taking the grandest, most intimidating concept in higher mathematics and placing it right next to garden gnomes and mythical fairies. The point the source is making is crystal clear. Infinity is a fictional construct of the human imagination. It's an invention, a complete fantasy.
The text actually concludes its argument on infinity with this final thought: it does not exist, but it might give you pleasure. The source is entirely uncompromising on the reality of infinity. It flat out does not exist. However, there is this little concession that, thinking about it, playing with the symbols, and engaging with the concept might bring us joy or intellectual satisfaction. It's a pleasing thought experiment. Much like reading a great fantasy novel about fairies or gnomes, we can derive immense pleasure and utility from the story, even if we know for sure the characters aren't physically real.
And that leaves us with this final, echoing question to ponder. Is the math we rely on every single day, the math that lands rovers on Mars and powers the exact device you're using right now, is it all built on a foundation of useful fairy tales? If, as our source argues, irrational numbers are really just approximations, number is totally undefined, and infinity is basically a mythical gnome that merely gives us pleasure, well, what does that say about our grip on reality? I really hope this explainer has sparked your curiosity and given you a completely new lens through which to view the numbers all around us. Thank you so much for joining me, and keep questioning everything.